In this session, we will be doing exploratory data analysis of cars data, which will include the data understanding, data cleaning, and data exploration, and we will try to take some insights from the data. For this, I will be using a car data set. So let me open the source of the data. So I have the CSV file, which is having, so first of all, let us try to understand the source data. So I'm having a CSV file of car data. So this is the CSV file of the car data. And so let us try to understand this file first. So my first column is car ID. So this is the consecutive number, serial number 1, 2, 3, 4. Then we have this symboling 3, 1, 2. Then car name, there are some Alfa Romeo, BMW, etc. Fuel type is gas, and then we have this aspiration, which can be standard or turbo. How many doors, the number of doors in a car, 2 or 4. Then the type of the car body, then wheel drive, engine location, wheelbase, car length, cylinder, engine size, etc. So all in all, we have quite a few number of columns, and at the end we have this price of the car. So basically our objective in this, we have to find out any insight that we can get from this data considering the price. So basically we want to find out what are the factors that actually impact the price, and also we want to find out is there any relationship between the various variables and various columns. Like suppose I want to know whether my price of the car depends on which factor. Is it your car body, or is it your drive wheel, or is it my length of the car, etc. So this is what we are going to do here. Second thing, we also want to find out if there is any value which we need for data cleansing. Like suppose here I can see, like under the engine type, I have this this string which is I don't know what is the use of this one. So we will know when we do our actual, when we will upload this data and do our actual data cleaning activity. So now I'm going to upload this file into our Python, and then we will start the data exploration. Let us now upload the file into the Python, and then we'll play with the data. We'll try to find some insights from data, and we will do some plots. So first of all, as you are aware, we'll upload the library. We'll import the libraries to be used in our programming. Import NumPy as NP, import Pandas as PD, import Matplotlib plot as PLT, and import Seaborn as SNS. So let us execute. And now we will upload the file here, pd read underscore csv. What is my file name? File name is car price, which is a CSV file. CSV, execute. So it has been uploaded successfully. So cars head, let us see, let us verify. So first 5 rows have been selected. From this we can say that there are 26 columns. So let us explore further on the data. Cars.info. So here we have around 26 columns, and there are 205 rows in each column. So from this you can get an idea of the data type of each column. So I have car ID symboling, which are the int64, then car length, car width are float64, then there are some object data type. Now the tricks for the data exploration is that if there is numeric data, then we can plot, box plot, then density curve, density graph, and then we can do scatter plot, etc. But again, it will come on the experience and as and when you will start doing the programming for the Python. Because if there is a large data set, then you cannot obviously plot the graph on each and every column. Based on the data, based on the source data, you have to decide that which columns are useful and which columns are not useful, and then only you can decide to plot the graph against them. And again, it depends on your business decision. Let us now focus on the column symboling. A quick Google search on the symboling indicate that the lesser the value, the less riskier the car is, and the more the symbolic value, the more riskier the car is. So first of all, we will see how many cars are having symbolic values. We will do group by symbolic. So for this, I'm going to create a data frame, and then I will select symbolic to value counts. So it will group by symbolic values. To see the output, you can do printf. So here we have, so -2 and -1, there are 22 and 3 car, and then the highest number of cars are 0 and with 1. Let us do some plot on this one. SNS box plot. Since this is a number, so we can first try to draw a box plot to see if there is any outlier and what is the mean value. So copy. So here from here you can see that the 1 is the median value of the symbolic. So majority of the car is having 1. So 1 is the median value. So let us see the distribution plot. This plot, then copy from there. So I will also draw bars. So here we have, so from the outcome, even the graph tell the same story. The 0 and 1 are having the maximum car. So let us see the relationship with the price. So for this, I'm going to draw a bar plot. So where my x axis will be symbolic and y will be price. So you can put y equal to price. Let's see the output. We are having the error because we did not mention the data, and then our estimator will be NP. Let us see the first sum. Okay, so from this we can see that car with the 0 symbolic have the highest price, but our parameter is sum. So let me change the parameter to median. Okay, now this gives the true insight of the data. So as I told you earlier, the lesser the value of symbolic, the lesser the riskier, lesser the car is riskier. It means by right the price of the car should be higher. So which is true from this data. -2 and -1 are having highest median price. But then there is also one insight from this data is that as the symbolic value increases 1, 2, 3, the price also is increasing. So it means that there are some other factor which is causing the car price to increase. Now we'll focus on another column, which is, let's focus on cars aspiration. I will change this to category, and then I will do value count to do a group by. Close the bracket and then print df. Okay, standard and turbo. So turbo is having 37 and standard is having 168. If you do a Google search on the aspiration, it means the way the car takes in the oxygen. Standard means the standard atmospheric pressure, and turbo means it's the pressurized oxygen. Since oxygen is a catalyst to the fuel, it means if the oxygen is pressurized, the car price should be higher. So let us see from the graph if this is really true. So for this we are going to draw a bar plot. So you can copy the previous one and then you can replace the aspiration value here. So let us see the output. Okay, now from here you see the turbo is having very high median price. So this is as expected. So now my next column will be, I'll copy this one and I will simply replace my columns here. So now let us focus on the column. So we can take in drive wheel. Let us see drive wheel. Okay, FWD, which is forward drive wheel 120, RWD 76, and 4-wheel drive is 9. So let us see how the price is varying on this one. So again what we will do, again we will copy this one and then just change the column name. So here the RWD is having the maximum median price. Now let us see the another column. I'm going to take a distribution plot for the weight of the car. So cars. So the column name is car weight. So let us see the output. Okay, so the majority of car are concentrated in between 2000 to 2500 car weight. So basically car weight is the weight of the car without the occupant. I mean there is no passenger, there is no driver in the car. Now I want to see how the price is varying with this car weight. So for this I'm going to draw a scatter plot. So I just change, for the scatter plot we will use a join plot function, join plot, and then we can put the columns here. Price, execute. Okay, from this you can see that as the car weight is increasing, the price of the car is also increasing. But then there are some cars where the car weight is increasing but the price of the car is down. So these are the small insights which you can get from the graph. Let us see another important indicator, which is stroke. What I will do, I will copy same plot and then I will change the curve weight to stroke. Oh, from this graph we cannot estimate anything, we cannot find out anything from this graph. So for the stroke I'm going to draw a distribution plot. Stroke. Okay, the majority of car is having 3 to 3.5 stroke. Let us now focus on the compression ratio column. So for that I'm also going to draw a distribution plot. Just change the column name. Compression ratio. So from this we can say that the majority of cars are having low compression ratio and there are few cars which are having very high compression ratio. So let us see if the price is varying based on the compression ratio. For this I can use join plot. I can copy one of the previous code. Just change the column name of compression ratio here. From this graph we cannot conclude anything. If you see the trend of the price increase on the lower compression ratio and on the higher compression ratio is almost same, but the majority of cars are having low price and low compression ratio, which is as expected. So let us do a plot on the price column itself. For this plot, So again here the majority of cars are having low price. Let me do a box plot. Let's see if we can find out anything on the box plot. Box plot. So cars price. I want to see my box plot on the y-axis. I just put y here. Okay. Now from here you can see there are few cars which are very highly priced. And if you see from the distribution plot also, there are few cars more than 40,000 which are highly priced here. So here also you can see in the 40,000 range there are few cars, and then there are cars in 30,000 to 35,000 which is here. But then majority of the cars are in the range of 10,000 to 15,000. So here also you can see it's a normalized curve. So we have another function, another plot which actually shows the variation and relationship between the various numerical column. Basically it tells the correlation among the various column which are numeric in nature. So for this we can use pair plot. So it is going to plot each variable against each variable. So suppose there are 5 numeric variables, so it's going to plot 5 into 5, 25 plots. But then you have to be very careful with the amount of data which you are having. Suppose if you are having 40 columns, then 40 into 40, 160 column, obviously it is not recommended. So if you are having lesser columns, then you can use the pair plot. But then for the higher, for the more number of columns, in such scenarios, you have to select only few columns to have a pair plot. So let us plot this one. It will take some time to come up with the result. So here is my output, but my output is not readable because as I told you that it's going to plot the number of times the column. So we cannot read the output. But then we have another beautiful option to use, which is known as the heat map. So for the heat map, first we are going to find the correlation between all the columns with the help of for function. And then I'm going to print. So here is my output. So I can convert this value into the heat map. So let us first try to understand this output. If you see, each column, like symboling, is related to each other column. Like symboling is linked to wheelbase by a factor of minus 0.53, is related to car length by a factor of minus 0.35. It means that if the value of symboling is higher, the value of wheelbase and car length will be lower because of the negative sign. Let us see if there is anyone positive. So horsepower is a positive to symboling. Then highway MPG is also positive. Let's see another simple example, horsepower. So if the horsepower is higher, what do you think the price of the car will be? It should be higher or lower? Let's see. Okay, my price is related to horsepower by a factor of 0.80. So it is quite highly correlated to the price of the car. It means that the higher the horsepower, the higher is the price of the car. Let us see if we can implement it on a plot. So for that I'm going to use the heat map. So for that I'm going to set the size of the figure first. We can do by fixed size 15:8 and SNS heat map. So here you have to set the color code. We're going to set white, yellow, green, blue, then anode true. So plt.show. So here's my output. Let's understand this one. First let us understand the color coding here. So higher the value, the darker is the color, and the lower the value, the lighter is the color. So our target column was price. So let us see the price column and which other variables are related to the price column. So let us focus on the darker color. Let's see, 0.87 is the darkest color. So what is 0.87 related to? Is the engine size. So obviously if the engine size is higher, the price of the car should be higher. So this is quite understandable. Even the curve weight, if the weight of the car is higher, the price of the car is also higher. In 0.84 is highly correlated. Let us see some lighter one like symbolic. Symbolic is negative minus 0.08. It means that from the previous discussion, from the previous session, we have seen that the higher the symbolic, the more riskier the car is, and that is why the price of the car is lower. Let us now do the data cleansing on the car data set. So let us see the data first. This is my car data frame. So the very first step in the data cleansing activity is to identify the missing value. So for the missing value, we will use is null. So if it is false, so there is no missing value, and if it is true, it means there is a missing value. So far I cannot see any true values here, but let us see the summary. Okay, now this gives the column wise missing value. So I have here all the column, and in all the column the value are 0. It means there is no missing value. So let us find out with is null dot any. So this is also false here. So car is any. Let us see row wise if there is any missing value. So what we will do here, we will put any and axis is equal to 1. If axis is equal to 1, it means it's a row wise. So even row wise everything is false. It means row wise also there is no missing value. So basically these are the standard steps which you need to do in every data set, with every data set. So you have to identify what are the missing value column wise, then identify what are the missing value row wise, and accordingly as per the business decision you have to treat the missing value. So far in our data frame there is no missing value. Let us revisit the data frame again. So here I have a car name. So what I want to do is that now here it shows the company name and it shows the make it shows the model of the car, like Audi 100 LS, Audi 100 LS. So what I want to do, I want to extract the actual car name, the actual company name from the car name, because the company name is also one of the factor to determine the price of the car. Now to extract, if you see the format here, let's see Chevrolet, Impala. So Chevrolet and then Impala. So there is a dash, there is a space between these two. So we can use a split function to split Chevrolet and Impala, and then Chevrolet will be my company name of the car. So for this I'm going to use the split function, and then I'm going to use the lambda to apply on each column, each value of the car name. So I will define a new column here, company name equal to cars. So car name is the column, apply. I'm going to use a lambda function, lambda x colon x dot split. Since we want to split over the space, so just give the space here, and then I want to start from the first value. Execute. So it has been executed successfully. So let us see the car. So on my last column you can see the name of the company here, company name. So let us group by the company, cars, company name as type, category, and then value underscore counts. The spelling error, I think. Okay, now these are the number of cars against each company. Now if you see here, the Toyota and the Toyota, the spelling is wrong, this spelling is wrong, so we have to replace this Toyota with the correct spelling. Same way you can see Volkswagen, then Volkswagen, the spelling is also here is wrong here, if you see here, so we have to change it. Even we have VW is also Volkswagen. So you have to standardize the spelling name. If you don't change the spelling name, so it will not give the correct business result, because the data frame will treat these two different car company. Now to do that, we are going to use LOC function. Let's see, cars LOC. You can also use here if else if condition here also, but then if else if will be quite long. So the easier way is to do with the help of LOC. So what I'm going to do, company name, so equal to, let's say, Toyota. If it is equal to Toyota, I want to put the correct spelling. And if it is not Toyota, it should be still be company name. So let us see my output. I can re-execute the same code here, and there should be not be any Toyota here. So now my Toyota count is 32, and there is no wrong spelled Toyota. Same way you can repeat this one over other car model. You can simply copy paste it here and change the model of the car. Let me change Porsche. The Porsche spelling is wrong here, so we just put the Porsche, and then correct spelling is this one. If you look closely, here we have PORC, and then here we have PORS. So I'll just replace it, and then I will re-execute this one to find out if there are any more than one Porsche. So I have one Porsche here, and there is none other Porsche. So once you have replaced all the misspelled spelling, then what we can do, we can drop the car name, because this is no more useful, and we already have the company name of the car at the last column. So we'll simply drop this one. Now to drop, I can use a drop function. So I'm going to have a new data frame, cars. So dropping the car name, and axis equal to 1. So I have a new data frame. Remember that whenever you are dropping any column or deleting any row, you have to always have a backup. So what I have done here, I am dropping this one from the car data frame, and then I'm storing in the cars_1. So I still have my original column in cars data frame, and cars_1 will not have any car name. You can see here, and you can also query back the original data frame. Now let's say suppose you are a data analyst of your company, and the CEO of your company asks you to present your finding from the car data set. So how are you going to present? Obviously you cannot show your Python program to him. So for this you need to prepare a PPT. So here I have prepared, this is the format that we can follow. So first of all, you have to give the heading on the first page. On the second page, you have to identify the business objective of the case study and the strategy which you are going to follow. So here I want to identify the variable which impacts the price of the car. So the strategy that we have followed, then we have identified the key intuitive variables and plotted the density curve to find the distribution of data. Secondly, with the help of the scatter plots, heat map and bar plots, we will narrow down to the few key variables that directly impacts the price of the car. So these small things you can mention on the slide, but you cannot mention too much detail on the slide as it will confuse the end user. Alright, so whatever major graph and major plots that you have executed in your Python program, you can take it as an output and you can display on the PPT for the other users. So like here, the price is highly positively correlated with the wheelbase, car length, car weight, and then price is negatively correlated to city MPG, highway MPG. So the car having high mileage falls in the economic category. So the economy category cars are small and mid-sized car. So let's see this next line. In the next line, you can plot the individual variables. So here I am plotting a density plot like car weight and stroke. So the majority of cars are having car weight of around 2000 to 2500 and engine stroke of 3.0 to 3.5. Note that whatever I am showing is just an sample. So here you can plot a 4 density plot, or you can plot business decision or the business outcome which you see in this. So here I have a variable versus price. So there are few key variables that we have plotted, like price versus aspiration, price versus drive wheel, price versus symboling. Mention here your key insight that you have found out. So your PPT should be very crisp and it should be comprehensive. It should cover all the major findings that you have done in your data analysis, so that the business user or the end user can conclude, or they can do some analysis for their business.